developing and applying the quadratic equation. So first what we need to take a look at is radicals. We want to be able to simplify them. So if you look at the radical here, the number underneath the radical sign is called your radicand. This number right here is your index, and this is your radical. Sign, symbol, whatever you want to call it, and the entire thing all together is the radical. So when we're simplifying, if we wanted to simplify any radical, we have to first take a look at the index. So what we're going to be generally dealing with is square roots. So I'm just going to go over square roots. So we need to remember our square numbers. Just try to remember them always. 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, and 144. Just keep in mind those square numbers. The faster you can remember them, the faster it will help you solve the radicals. So if I want to simplify the radical, what we're going to do is you're going to find a perfect square that divides into the radicand, so your inside number, and you're going to split it into two radicals, take the square root of 1, and write it as a mixed radical. And a mixed radical means you have a number out front and the number on the inside. Doesn't matter what they are. So if I take my first example, root 40, we want to find a square number that's going to divide into 40, and so that's 4. So we're going to write it as 4 times 10, because we can do 4 times 10, and that's 40. And then we're going to split it into two radicals, and you can take the square root of 4, which is 2, and all that's left underneath the brackets is root 10. So this is your mixed radical. For our second one, we need a number that goes into 32, which is 16. And always try to find your highest number that goes in. So 16 times 2, write it as 2 radicals. And the square root of 16 is 4, so we're left with 4 root 2. And for the last one over here, a number that goes into 53 is 9 times 17. And 17 is a prime, so you know that no other numbers bigger are going to go into it. So it's 9 and 17, so we're left with 3 root 17. And for the last example, let's go with 108. I'm going to divide I'm going to divide 4 into this one. So if I take 4, it's going to be 4 times 27, which is root 4 times root 27. We'll get 2 root 27. Now if I look at this 27, I know that 9 goes into it. So we can break this up again to 9 times 3. So it's going to be 2 times 3 times root 3, which is 6 root 3. The reason why this happened is because we know that a bigger square goes into 108. So rather than, you can do it this way and just keep breaking it down until you get this number to be something that can't divide into a prime, or you check for the highest number that goes into 108. So technically, the higher number is going to be 36. So 36 times 3, root 6 times 3, 36, which is 6 root 3. So it's a lot less steps, and you get the same answer. So if we want to simplify an equation, we want to simplify this 50. So a square that goes into this is 25 times 2. Take the 25 out of the square sign, and we're left with 5 root 2. For our second question, 2 plus or minus 36 times 10 will work. So we take the 36 out from underneath the square root sign, and it's 6 root 10. The next one, negative 5 plus or minus 9 will go into 45, so 9 times 5. So it's negative 5 plus or minus 3 root 5. And for the last one, 405 is divisible by 81, so we have 81 times 5, so 1 plus or minus 9 root 5. If you want to prove the quadratic formula, you can do this by completing the square. So we want to move our x's to one side and our c to the other. So now we have to get x by itself, so we're going to divide by a. So we have x squared plus x equals negative c over a. We want to find our new c value. Oops, sorry, this is a b. Let me write that properly. We want to find our new c value, so it's going to be b over 2a squared. So it's b squared over 4a squared. So we want to add that to both sides. So if we factor this, it'll be x plus b over 2a squared equals. Now, if we want to add these two, I'll do it over here on the side. We want to make our denominators the same, so we have to times it by 4a. So we've got 4ac over 4a squared plus b squared over 4a squared. And I'm going to put my b squared first because it's positive. So on the right side, we have b squared minus 4ac over 4a squared. Now we're going to take the square root of both sides. So we have x plus b over 2a equals plus or minus the square root of b squared minus 4ac over the square root of 4a squared. And our last step, and 4a squared is the same as 2a, right? So our last step is to move our b. So we have x equals, and because our denominators are the same, we can combine them. Negative b plus or minus the square root of b squared minus 4ac over 2a, which is our quadratic formula. And you can't even see that that's a 2a, but it's over top of 2a. So if I take the equation x squared minus 2x minus 7, we're just going to fill in our a, b, and c values. So a equals 1, b equals negative 2, and c equals negative 7. So x equals negative b. We're using our quadratic formula. So negative negative 2 plus or minus the square root of negative 2 squared minus 4 times 1 times negative c divided by 2 times 1. So this turns into 2 plus or minus 4 minus 4 times negative 7 is positive 28 divided by 2. So it's equal to 2 plus or minus the root of 32 over 2. Now to simplify this, 2 plus or minus 4 root 2 divided by 2, and you can take a 2 out from all of these, so it's 1 plus or minus root 2. That's your simplified answer. For the next question, a equals 1, b equals 2, and c equals 7. We have x equals negative 2 plus or minus the square root of 2 squared minus 4 times 1 times 7 divided by 2 times 1, negative 2 plus or minus 4 minus 28 over 2. Now 4 minus 28 is negative 24. And because we can't take the square root of a negative number, our answer is no real roots.